Hey everybody, welcome back to another episode on the Easily Amused channel. I am Andy Brady. Thank you for joining me. Today we are going to, as the description says, talk about adding keyhole slots to your designs in Onshape. Onshape, as you may know, is an AutoCAD software. It is free to use. It is fantastic software, and I am no professional, so I'm learning as you are learning. But I was trying to find the best and most efficient way to build a keyhole design into a 3D print, and after some success and some failure, I came up with what I think is the best option, at least for me, and hopefully it'll work out for you and give you some ideas for you to be able to do it yourself. But stick around. Let's see what we got going on. All right, so what are we trying to do here today? Well, it's pretty simple. My daughter won the game ball. Pretty simple, right? I want to make a display for it. And I searched Yegi, I searched Thingiverse, I searched Maker World. I didn't find anything that I liked. I didn't want to put it on a shelf to display it where it'll just get lost, knocked down, whatever. I wanted a wall mount, and I wanted it to be something strong, something stable that would hold this ball in prominence so that she can be proud of it for a very long time. After searching for quite a while, like I said, I didn't really find anything that stood out to me. And so I decided, let me jump on Onshape and let me design something myself. And a quick shout out to Teaching Tech channel, which I will put a link to in the bottom. He's got a couple videos that kind of introduce you into using Onshape. And up until I watched those videos, I was strictly using Tinkercad, barely scratching the surface of what a 3D printer can actually do because I wasn't customizing the need to myself. So please check out those channels. Great content, really going to get you going on that. But instead today I want to take it one step further and talk about something that I did not find any videos or really any instruction on the best or easiest way to make a keyhole. So keyholes are these slots that you see all the time in things that get hung on the wall. A screw goes into the large side, and typically it'll hang, sideways like this, which I don't prefer because as you can see, it'll hang, diagonal sometimes, or sometimes it'll be at the very top and it'll rest right in the middle, and it can't come off the screw, so you can put this screw in the wall and immediately hang it. Now, sure, you could, with something as lightweight as a, coach pitch softball, you could just use some double stick tape. You could tape it to the wall. There's lots of things you could do. But I actually have a log cabin, so my walls are shaped like this. So the only real option that I have is to put a screw in the wall and hang it. Plus, let's be honest, it's going to be the most secure method. So if you look at the video down here, what I've got going on, this is the Onshape design that I have. Very, very basic, not looking for anything super special. I might add some words here, but if I do, I'll probably do it in the slicer software. I find that to be a little bit easier. There is the ability to add words right here in Onshape, but following curves, things like that just seems to work a little bit easier in the slicer. But I'm really thinking I want to leave it alone because they wrote right on the front of the ball. So for me, for these purposes, this is, simple and to the point. Couple quick things I want to point out before I get into the keyhole designing is how did I come up with the size for the hole, right? So there's all kinds of tools that you can use to try to figure certain things out. I could have just Googled how big is a softball, but by age, coach pitch, T-ball, fast pitch, all of these things change the size. You could just measure it with calipers, but I'm a strong believer in tactile feel and seeing what something actually physically feels like. And sometimes that means wandering around your home and finding the right thing. I happen to find a kid's cup, and the kid's cup happens to hold the ball perfectly. And it's nice and stable. It's a good size. It shows most of it. You can still read the printing on it. And so I decided to make the main outside rim of the hole this size. I also know that, it ends with 0. So as long as I shape it down in that kind of curvature, then it should hold this ball absolutely perfectly. I was going to do a circle on this backdrop right here for the inset, and I was looking for a shape to do that. Now I ended up not doing it, but I wanted to show you guys what I was trying to design. I actually found my good old Glencairn glass, if you like whiskey and you follow any of my whiskey videos, that it was actually the perfect shape in order for me to be able to make a more compact designed thing. And then all I'd have to do is measure this and measure this. And yes, I went through lots of different sized round objects in the house, and I happened to find 2 cups that worked perfectly. So that's how I came up with the exterior measurements, and originally the backdrop measurements that I have decided against. But I just like to discuss, sometimes putting your hands on things is a very easy way to come up with the solution that you might be looking for. So the next part is I want to add a keyhole right back here. I'd like to not have a sliding keyhole where you've got to come up with the center and you got to balance it, and then kids run around the room, the walls shake, and suddenly it's off center. Instead, I would like the keyhole to be perfectly centered in the middle, so that when the screw, wherever I put it, when the screw is slid in, as long as I have it perfectly centered, then it will actually use the weight of the softball and the build to perfectly balance it at the bottom. And so even if it gets knocked or shaken or whatever, it should settle back down to the middle. So that's why I'm going to be putting that keyhole in the middle. So first off, in Onshape, there are a lot of custom features. You can come in here and you can search for keyhole, as you'll see, and do a search, and it'll show me every project with the word in it, but I want to specifically look at features that you can add. And these are features that are made by individuals that they have uploaded and made available in their feature scripts. I tried all 5 of these, and I had a lot of trouble figuring out either how to use them or how to use them efficiently in a way that actually made sense. And by the time I got done playing around with it that much, I realized it would just be easier just to use the knowledge I already have about Onshape and redesign it in a way. So what I want to do is I want to show you how I did it, because it is very quick, very easy once you get the hang of it, and I think it would be very helpful to a lot of people that make things that do hang on the walls. So first and foremost, let me open up my first original sketch. This was what I started with, very basic, very simple, and I am going to get the line tool. And I'm going to make sure that I'm centering it because I can. And by centering it, again, I can make sure that weight stays based somewhere. And I don't really care how far down I draw it, and I don't really care how long I make it right now, because I'm going to be adjusting that. But now that I've made the line, this is kind of the start of the slot for the keyhole that I'm making. So let me go ahead and put a measurement here, and let's do it about a 1/2 inch, 12 millimeters. And then I'd like the overall slot. Well, I don't know how long I want to make it. Let me look at this one and get an idea of if I am putting it in here. Well, this is a very long slot because you're trying to balance it. So I don't need that. I just need it to rest at the top. So I guess I could make it significantly shorter than this. So, just pulling out a standard, ruler. Oh, those are inches. Pulling out a standard ruler, I'm looking about 35, and if I center it, which you'll understand in a minute where the points would be, probably closer to 30. That's a little too long for what I need. Probably be just as happy with about, let's do 20 millimeters. It won't hurt to have it be a little extra long. So let me come right here, and I'm going to change the measurement tool on here as well, and I'm going to make this 20 millimeters. So what I'm doing is I'm basically drawing the middle of what the keyhole slot will be. So the next step right here, usually offset tool is the most used, so a lot of times that's what's written right here, but I'm actually going to be using the slot tool this time. If you've never used it, what it does, it basically does an offset, but it's going to make it rounded. So I'm going to select that line, and I end up with an offset. That's going to be rounded along the top. You'll notice that there's a 6 right here for 6 millimeters. That is actually a measurement between these 2 points. So the horizontal, or the parallel lines. That's what that measurement actually is. So how big do I need to make that? Well, let's figure it out. So I need something that this can slide into and retain. So I'm going to use this tool. This is actually a tool I'm going to shamelessly plug that I have put on printables. It is fantastic. I use it all the time. It has 1 through 7, and then I also have 8 through 14. And what it does is, that's 7 millimeters thick. That's a 7-inch hole. That is a 7-inch or a radius of 7. And the same on the front, 7 millimeter radius on the front. So this gives me the ability to feel the size. It gives me the ability to, drop a screw in and see how loose is it, how much wiggle room do I actually have. And by doing so, there we go, the 6. Very easy to get in and out of. I want it to be able to slide up and down. I don't want it to bind. I don't want it to be too big where you end up with so much wiggle room that maybe it doesn't end up centering and plumb bobbing itself. So it looks like here, 6 millimeter would be a good size for a slot on here. So funny enough, it's already set to 6, so I'm just going to leave it there at 6. Now, here's what's going to happen. Since I'd already designed it and I had already extruded it, the moment that I added a circle, that circle is no longer part of the extrusion. So easiest way to do it, I like to have my sketches visible anyway, is go to my original extrude, select that, and now it is flush because that is also been extruded 10 millimeters as it was before. Now there is a hole here. All right, sorry about that cut there. I actually had forgotten that I had tinkered around a little bit and I had done an extrusion that I completely forgot that I had to undo so I could then show you what it was I was doing. So anyway, I've got the circle cut out for my slot, and I know it's going to be 6 millimeter. And how deep do I need to make it? Well, this is 10 millimeters deep because I know that's how big I made the original sketch before I extruded it. And, you know, looking at this, just want to show you guys an example. Sometimes you can make the slot too tight to the point where you tighten this into the wall, into the door, whatever it might be, and then you get the screw in and it just won't lock into place because there's not enough room to get it to go up and down in the slot. So you want it to be tighter in an environment where it's going to be moving around. You're going to want it tighter maybe if you're hanging it on the back side of a door, it's getting opened and closed. But if it's just going on a wall, you can kind of play it loose with your figures, with what it is you're trying to measure out here. So what I'm going to do instead is I'm going to simply take, you know, my calipers. I'm going to find out how big is the head of the screw. And then from there, I'm going to stretch it out a little bit. How much? I don't know. Just a little bit of wiggle room. And yeah, that would be enough without being too much that if this is what was actually holding it in place, I think that would work. And that actually, that's hilarious. That's exactly 5 millimeters. So I like even numbers, so that's what I'm going to do. I'm going to make the slot that actually holds the pan head on here 5 millimeters. So I'm going to start by selecting that part of my sketch, and I'm going to extrude it. And I do not want to add, I want to remove. And I needed to remove from the thing, so I'm going to go the opposite direction, but I don't want a hole all the way through. So 25 millimeters is too much. 5, enter. And now I should have a 5 millimeter slot right there. Perfect, exactly what I wanted. Now, you'll notice the slot is flat at the top right here where I'm highlighting. So, you know, if it was a piece of plastic perfectly flat, you try to hang a screw from it, it's just going to slide off. There's nothing there to hold it in place. Also, this slot will only hold the threaded part. There's nowhere for the head to go in. We're getting there, don't worry. What I have found works really well, and there's a couple different ways of doing it. First, I'll tell you what I don't like. One, you could offset the inside of this and you could actually end up with more of a structure like this where it is actually a flattened area right here. The reason that I don't like to do that whenever I'm creating something that I hang is this was created by a router bit, went in, down, back, it was done. Super easy. This is going to have to be 3D printed. And when I go to 3D print it, this little standout section will be sticking out in multiple different directions, and it's going to need some kind of supports. And if you're okay with doing a bed support up to here or even a support from in here up here, you know, whatever. People aren't going to see the backside of it. You can rip it out with a pair of pliers. You'll be good to go. But I really do like to try to design things that just need absolutely no supports, less likely to fail. So that's definitely what I prefer to do. So what I'm going to do is I'm going to click right here and I'm going to click the draft button. And when I do, it's going to suggest 30 degrees. That's just kind of where it defaults to. Oh, select it again. Apparently I had not. There we go. And it now has a 30-degree draft. Now you'll notice it can't just draft one side, so it actually ends up drafting the entire opening all the way around, which I don't really care about it at the bottom, but it's not hurting anything, you know, being drafted all the way around. So 30 degrees, I've actually used it in the past. It works fine. I found that out because I tried it once at 30 degrees and it worked, so I left it there. So it suggests 30 degrees, I leave it at 30 degrees. So now I have set that draft and you can see that it is now a slot where the inside is bigger than the 6 millimeters, which means it is big enough to hold this. And if you really needed to, you could grab this measurement tool down here and you can measure the inside to inside and make sure. But again, at 30 degrees, it's expanding pretty drastically there. I see no reasons it would not fit. But you know, after I print it one time, I guess I could find out that I made a mistake and I should have pre-measured. But you'll see here, this point is extremely sharp. It's going to be 1 layer line thick, and 1 layer line thick is not going to be enough. You know, the weight, even if it is lightweight, pushing down, it's going to start bending the plastic, And unless it bends it specifically at this point right here, you're going to end up with, something that got knocked sideways. Maybe the ball got put back one day and it got knocked a little bit sideways and now it doesn't hang level. You don't want to have to reprint this. So the easiest way that I have found to really support this and build it up is pretty easy. I made this thickness 10 millimeter. I actually wanted it thicker than that. You'll notice this is thicker. So what I'm actually going to do is I'm going to select all 3 of these surfaces here because there are 3 in my design. If there was only 1, I'd only have to select 1. And I'm going to add yet another extrude. This time I'm going to thicken it. Don't need to reinforce. That's not going to do any good. So I'm going to thicken it, and I'm going to thicken it by how much? Well, let's get an idea. Again, using this gauge right here. So, 1 millimeter, it's not really going to add a lot of flat space. It is a little bit flexible, but that's okay because, again, you're going to have at least 1 layer line. 1.5 seems pretty good. 2 seems pretty good. That'll give me a good hold. I think I'd probably be good with either 1.5 or 2. To save on plastic, let me just use 1.5. There's, again, this is going to be a very lightweight piece, so I'm not really that concerned with it being damaged. It's probably never going to be touched again after I hang it up. But now you can see that beyond the draft, the chamfer kind of going back in here, I now also have this 1.5 millimeter flattened surface that should end up being a couple layer lines and will add to the durability of where it's actually going. So now we've got our slot built. We've got our inside inset to hold the head of the screw without having an issue. What's next? Well, let's go back to our sketch number 1. And the great thing about building 2 lines and having this slot is it rounds it around the perfectly centered place right here. So what we're going to do is we're going to grab a circle, center point, and we're going to make a circle. And I don't really care how big, because now it's time to make a measurement and figure out how big does it need to be. You could, again, just grab calipers. This is 8 millimeters is the size of that head. But again, that doesn't really give you any kind of tactile feel. I can make it a little bit bigger and I can kind of see. If I had something around the house, oh, I sure do. I have a measurement gauge. I could simply put it through this hole and see, is that going to be big enough, right? Which this is standard measurements. I've got a metric one around here. So, a 3/8 inch hole is pretty sizable. It works pretty well. It goes in and out, no problem. You can use anything. The hole on the end of this ruler, that's not going to fit. Nope, sure doesn't. But if it did, you'd be able to get an idea of something. How does it feel, especially if you're using something else? And so what I'm actually going to judge mine on is this hole right here. It's nice, perfect size, have it in the house. I know that it fits through there. So I'm going to take my calipers, measure the inside of that hole, and it is 10.25 millimeters. So let me grab my dimension tool, and I'm going to set it over here, 10.25 inch circle. And watch what's going to happen whenever I hit check, because this is kind of funny. I have drawn yet another circle, and what did it do? It put a hole all the way through. And if you remember what I did last time, I'm going to go back to my extrude number 1, very first one I ever worked with. I'm going to re-extrude that. I'm going to add that to what has been extruded, and look at that. It is flush on this side, and now on the back side, it is inset by the 2 millimeters, because I did not extrude, or 1.5. I did not re-extrude the 1.5 millimeters here, which is okay. Instead, I'm going to go back to my extrude number, let's see, 3? Nope. Where's my extrude on this one? Stop selecting things. Eventually I will get there. This is extrude number 4. All right. So I can just add to extrude number 4 this right here. And you'll see now my keyhole is extruded the same depth. Cut that. That did not work, because what that did is it destroyed my draft. So I'm going to undo that, and I'm actually not going to cut that out of the video. So now I just need to know that my extrude number 4 was 5 millimeters. Remind myself of that. Click on this, and I'm going to do a new extrude. And I'm going to do another removal, and I'm going to go in the other direction. And I'm going to go 5 millimeters, and you'll see that it now lines up perfectly. and did not mess up my draft. See? So we all learn. I definitely made a mistake there, but that's good. So now you can see that the keyhole is large enough there to allow it to go in. We know that because we tested it. And we now have a slot that is built all the way up through here. We also know, because of 3D printing, design work, that this was exactly underneath the middle of this arch. So it should hang plumb no matter what I do. And there is a very basic, very straightforward keyhole that should print without the need for any supports whatsoever. In fact, let me jump off here and let me put it in a slicer and let's see what it looks like after that. All right, so here we are in our slicer software, which of course my AMS is out of sync again. And you'll notice that it put it with the keyhole down, which would require supports. Maybe not. It could probably bridge those lines pretty easily, but it would definitely require supports up here at the top of the circle of the opening. So not interested in doing that, but it laid it this way because when I designed it in Onshape, this was the back of what I designed, and that's why it did it that way. But anyone who's printed, y'all know, lay on face, there it is. Super easy to do. Put it right just like that. Let me change this color to a different green. All right, that PLA, and let's slice it and let's see what this looks like. All right, so here it is. And you'll see the only place with any overhang whatsoever is right at the very top of the keyhole, and there's very little. It looks like there's a 2, maybe 3 layer lines worth that it should not struggle with at all, but y'all know how it works sometimes. Up inside of there, there's a little bit, but you'll see because I built it the way I did, where I've got it at a slope instead of just carving out a hollow piece, it's able to actually build up to it. So I should end up with very little need for any overhang. There's definitely not a need for support here. This will take 1 hour and 22 minutes on the bamboo, and I'm going to change some of these settings to make this top end just be a little bit smoother, and then we'll go take a look, see it printing, and see how this works out. Oh my God, would you look how dirty my build plate is? Yeah, it's because I never, ever clean it. Yeah, for those of you who are new to the channel, you may not know, I really don't clean my build plate. It looks nasty, it looks disgusting, yet it still prints perfectly fine. And I do have my enclosure, and I do have my Ender 3V2, and I do have my Prusa Mark III Plus that I plan to upgrade, and my bamboo in the middle. And the reason I like to use the bamboo is because right now I have no idea if this is going to work. I have no idea if it's going to look good or bad, and it's going to be the quickest to print. But if I end up printing in PETG to make it stronger, probably going to end up using that. Anyway, let's see how it turns out. All right, everybody, there you have it. Ball stand ready to be hung on the wall. Keyhole on the back. Put a hole in the bottom so it nice and holds the ball. Actually, kind of looks like a toilet with the seat up. Very classy, I know. But you'll see, perfect keyhole, slotted on the inside, nice round bottom, ready for the screw to go in. Already tested it out, hangs on a wall just fine. You're gonna see I'm gonna upload a couple more of these designs, including size for a baseball, size for a golf ball, first hole-in-one, things like that on the golf ball ones, because there's really not much out there to brag and display whenever that does happen, if it happens. But check out our printables, Kabliga, K-A-B-L-I-G-A on printables, and you'll find all of these models. There should be a link in the description to our main page. And if this was useful, if you liked it, please like, subscribe, hit that notification button so that you can get notified when our next 3D printing videos come out. And thanks again for watching. Andy Brady, easily amused. Remember that uneven log cabin I was going to hang it on? Yeah, I lied.